Hi, both. Thanks for joining us today on our Business Gurus channel, where we will be discussing key business topics to help students grasp the most important elements of their course in preparation for their exams and future career. Let's get started.
Welcome back to the deep dive. We take your complex sources, boil them down, and give you the essential knowledge you need. Today, we're diving into something huge: technology's impact on, well, modern production and how businesses actually work. Before tech really took off, manufacturing often felt like a trade-off, didn't it?
Oh, absolutely. A strict choice.
Right. You could go for massive volume, low cost, but forget
Or
customization.
focus on specialty items, lots of variety, but then you lose the speed, the scale.
Exactly. So our mission today is to really pull apart how modern tech just breaks that old choice. We're going to look at the specific ways it drives improvements in two key areas: productivity, think speed and scale, and flexibility, that's about variety and being able to adapt quickly.
That's definitely the right way to frame it. We know technology speeds things up, sure.
Yeah.
But the sources really push us to go deeper than just saying it's faster.
Yeah.
We need to pinpoint the specific capabilities, the technical levers, the
Yeah.
things that let a modern manufacturer hit both high speed and high customization at the same time.
Yeah.
It's about how tech fundamentally changed the physics of making things, making those old compromises kind of obsolete.
Okay, let's unpack that first one then. Productivity. When businesses talk about tech boosting productivity, the classic definition is output per hour, right?
That's the standard metric, yes. Output per unit of time, usually per hour.
But let's talk scale. We're not just talking a little bump, like 5%.
Oh, no, not at all.
So what's the core mechanism? What creates these huge structural leaps in output?
Well, the main thing is replacing human labor with robots and advanced machines that just operate continuously. It fundamentally shifts the bottleneck.
Hmm?
It's not about human endurance or schedules anymore. It becomes about how long the equipment can run and when it needs maintenance.
And the really striking advantage there is the time, isn't it?
It's simple math, really.
Yeah.
Machines can run 24/7. That's 168 hours a week. Even a human-staffed factory running 3 shifts flat out. Well, they still have mandated breaks, shift changes, time off, holidays. You can't avoid it. So compare maybe a really efficient human line running, say, 120 hours a week to a robotic system hitting that full 168.
Hmm.
You've instantly gained nearly 40% more operational time, just like that.
And that extra operational time, that's the real engine of productivity gains, right? It makes everything else more efficient.
Precisely. This is where the idea of capital utilization comes in. Think about it. The heavy machinery, the factory building itself, all the infrastructure, these are massive upfront costs, sunk costs.
Huge investment.
Exactly. And if those assets are sitting idle for, say, a third of the week just because people need to rest, you're constantly reducing your return on capital employed. It's just unavoidable.
Mm-hmm.
So this 247 engine, the robotic automation, it ensures you're squeezing the absolute maximum value out of those fixed assets every single hour.
Okay, that really clarifies the financial push for automation, but here's the challenge. It always comes up in the sources. These robotic systems need huge initial investment, big capital outlay.
Yes, that's true.
Doesn't that cost kind of wipe out the hourly gains, at least for a while? Especially for, smaller companies.
That's a really critical point. And it highlights why only that continuous 2-1-4-7 operation truly makes the numbers work. If the gains were small, the cost would often be too high, you're right.
Okay.
But because these systems run constantly and consistently, which also means less waste, less variation, no unexpected human downtime, the payback period actually shrinks dramatically.
Mhm.
The sheer increase in total output you get from running nonstop, plus the guaranteed consistency, it rapidly overcomes that initial cost. It's a mechanism that almost forces a business to scale fast and just keep those assets running.
So productivity is fundamentally cracked by endurance. The
Yeah.
24/7 operation, maximizing asset use. It's about rate, about scale.
That's the core of it.
But, okay, maximum speed isn't much good if you can only churn out one single product forever. Which brings us neatly to the second pillar: flexibility. How do we get from just relentless speed to actual adaptability, being
Yeah.
able to change things up?
Right. Adaptability comes from swapping out fixed physical tooling for essentially flexible digital instructions.
Hmm.
And the key technology enabling this is computer-aided manufacture, CAM.
CAM. Okay.
We often talk about automation generally, but CAM is really the specific intelligence driving this flexibility. It lets the business use computer programs to precisely control, monitor, adjust basically every parameter of the tools on the factory floor.
Like what specifically?
Oh, the speed of a cutting tool, The exact path of a laser, the temperature for a weld, you name it.
So for listeners who follow the tech side, is this where things like CNC machines come in? Computer numerical control?
Exactly that. CNC machines are like the physical hands carrying out the CAM instructions, but what's really revolutionary is the integration, often called CAD-CAM.
CAD being computer-aided design.
Right. CAD is where you design the product digitally, create the model. CAM then takes that digital blueprint and translates it directly into the movement commands for the CNC machine on the floor.
Wow. So the ability to change the product isn't tied to physically rebuilding the production line anymore.
Not in the same,
It's tied to rewriting software code.
That is the absolute key technical takeaway. In the past, if you wanted to change, say, the dimensions of a part, you might have had to order or make new jigs, new fixtures, expensive dies, physical things that lock the machine into making just one thing.
Right, very rigid.
Very. Now, if you want to change the depth of a hole or the curve on a panel, you literally adjust the CAM program.
Yeah.
A few lines of code. And the CNC machine implements that change almost instantly, often with precision, tolerances far beyond what a human could reliably do.
That just completely changes the game for offering variety, doesn't it?
Dramatically lowers the barrier.
So if I'm running a factory and a customer wants a slightly tweaked product, I don't have to say, sorry, only if you order 1 million. I can just load a new file.
Pretty much, yes. The business outcome is agility. Real supply chain agility. This kind of precise computer control means a business can make a huge variety of goods, or even highly customized one-offs, without facing massive retooling costs or long delays each time.
So they can pivot based on what the market wants, almost in real time.
Exactly. Produce custom stuff in small runs one day, then switch straight back to high-volume standard items the next. This flexibility, driven by CAM, lets manufacturers actually meet the market's growing hunger for customization.
Instead of forcing standardization.
Right. You're serving the customer's desire for variety, not forcing them into your rigid production constraints.
Okay, this brings us to the synthesis. Putting these two together, we've got massive continuous output that's productivity from the 24/7 operation, and we've got massive digital customization that's flexibility via SAM and CNC. When you combine those two, what does it mean for how businesses actually operate, for the structure of production?
Well, it means the basic rules of production planning are just rewritten. Like we said at the start, businesses used to face a stark choice. Optimize for huge volume, like flow production, low cost, but zero variety.
The old assembly line model?
Kind of, yes. Or optimize for high variety, like job production, custom work, but slow and expensive. Technology now lets businesses operate in that sweet spot in the middle, which used to be almost impossible to reach efficiently.
It sounds like tech doesn't just make things more efficient, it fundamentally shifts the business model from being supply-driven
To being demand-driven, yeah.
because you can respond so quickly.
Exactly. When you can run 24/7 and change specs almost instantly, you become incredibly responsive. You can now do high speed and high variety production, often using the exact same machines.
That must give businesses huge resilience too, right? Against shocks in the supply chain.
Massive resilience. They can pivot rapidly if there's a material shortage or if consumer tastes suddenly change. They aren't locked in.
This new reality also makes us look again at the traditional words we use. The source material mentioned those historical terms.
Job, batch, and flow production, yes.
Right. Traditionally, job was the bespoke, one-off, super flexible model. Flow was mass market, identical products, Ford Model T style.
The classic assembly line, yeah.
And batch was somewhere in between, making groups of similar things.
Correct.
But if a single digitally controlled factory can switch from making a unique job order 1 hour to churning out a 1,000-unit batch the next hour, and then maybe run continuous flow production for the rest of the week, do those old labels even mean anything anymore?
They certainly lose their power as rigid ways to classify a whole factory or business. They become more like modes of operation, states that a modern factory can just shift between fluidly.
Okay. Modes, not fixed identities.
Exactly. They aren't permanent descriptions of the business structure anymore. The lines between job, batch, and flow are just completely blurred.
Blurred by that combination of 247 uptime and instant CAM reprogramming.
Precisely. Modern operations are really defined by their fluidity. They aren't in one category. They exist in this dynamic state that the software enables. Efficiency isn't about picking the right category up front and sticking to it. It's about having the tech infrastructure to execute any of them whenever needed.
That's a really powerful shift. and a great way to wrap up this deep dive.
Yeah.
So, if you take anything away from our discussion today, remember these two core impacts of technology. First, tech boosts production through sheer endurance, that 24/7 operation. It maximizes asset use and drives huge productivity gains.
Constant work cycles.
Second, it enables precise computer control, mainly through CAM and CNC systems. This makes production software-driven, instantly adaptable, and that delivers the crucial flexibility to meet all kinds of market demands.
And thinking about that combination raises a really interesting question for you, the listener, to ponder. Given how technology has basically shattered that old trade-off between volume and variety, does it still make sense for us to define production using those old terms? Job, batch, or flow?
Are they still useful categories?
Or do we need entirely new ways to think about it? New frameworks to describe operations that are both super automated and super customizable? Because that ability to pivot, to be fluid, that feels like the new definition of success in manufacturing today. Something to think about next time you see a product that's both mass-produced and somehow personalized.
Absolutely. The age of either seems well and truly over. Thanks for joining us for this deep dive into the engine of modern business. We'll catch you next time.
Thanks to both of you for joining us today. You've been listening to the Business Gurus. Let's now hand it over to you. What further questions do you have based on what we've discussed so far? Leave a comment and we'll get back to you right away. If you haven't already, hit that follow for more business tips.